Hello everyone, welcome to another episode of the Python Basic series. Today we will go more in depth about object-oriented programming. In today's video we will explain the concepts that are the backbone of an object-oriented programming language. Before we begin, I want to note that this video intends to provide you with a high-level explanation of these concepts and explain these concepts in a simple manner, so we will not be going very in-depth. We intend to provide you with the knowledge necessary to understand these concepts and explore them more on your own. Today, we will be covering inheritance, encapsulation, abstraction, and polymorphism. Those are some big words, but they should not be too intimidating for you to understand, so let's dive right in. We will begin our discussion by talking about inheritance. In our classes and objects videos, we talked about a car class that has several attributes such as make, model, color, and year, and behavior such as starting, driving, and turning off. Let's expand upon this example here. Let's say our car dealership also began selling motorcycles. That means we would need a motorcycle class in addition to the car class. However, the motorcycle class can have all of the same attributes and behaviors as this car class because they are both vehicles. What is the best way to combat this problem using object-oriented programming? By introducing inheritance. With inheritance, we can make a parent class that our child classes inherit attributes and behaviors from. In our example, we can have a vehicle parent class that has attributes such as make, model, year, and color, and behavior such as starting, driving, and turning off. Then, our motorcycle and car class can inherit these properties and behaviors of the vehicle class. In addition to the attributes and behaviors of the parent class, we would also have other attributes and behaviors unique to the child classes. For example, we might want an attribute for the number of doors in the car class and an attribute for the handlebar style in the motorcycle class. I'm clearly not a motor vehicle expert, but you get the point. Let's move on to the next aspect of object-oriented programming, and that is encapsulation. Broadly speaking, encapsulation refers to the idea that certain attributes can be encapsulated, which means hidden from the outside world. The outside world, I simply mean other classes. In practice, encapsulation is a means to control access to certain attributes and behavior by hiding them from other classes. As a programmer, you can decide which attributes and behaviors of a class are hidden or visible to other classes. Let's tie this back to our prior example of our car dealership software. We have a car class and a motorcycle class that inherit from the vehicle class. The motorcycle and car class each have attributes that can be hidden from one another via encapsulation. This also ties into the next concept we will discuss, which is abstraction. Abstraction refers to the idea that you can use a function without understanding or being bothered with the actual implementation of that function. Let's look at a real-world example of abstraction. You can start your car and drive without understanding or knowing how an internal combustion engine actually works. In object-oriented programming, abstraction works the same way. Because of abstraction, you can create objects and use functions without knowing or seeing the implementation of that object or function. Let's tie this back to our car dealership example. Let's say someone is using the software we have been creating for the past several videos. A user can add a car to inventory and the software will create a car object to do so, but the user has no idea what's going on behind the scenes. That is abstraction in practice. The final idea we will discuss in this video is polymorphism. Poly means many and morph means forms, so polymorphism literally translates to many forms. Broadly speaking, polymorphism is the idea that multiple types of child classes can use a function or attribute from the parent class without each child class needing their own version of that function. Let's bring this back to our car dealership software example. Let's say we want to be able to get a detailed report of each vehicle in our inventory. We could have a function in our vehicle class that prints all the attributes of that vehicle. Then, the car and motorcycle class can call that function to help us get our report. This simplifies our code because both child classes can use the function from the parent class without needing their own version of the function. This concludes our overview of object-oriented programming. I hope you enjoyed the video. As always, please visit us on Pyathlon.com or like and subscribe if you're watching this on YouTube. Thanks for the support, and see you in the next video.